So next example of linear application. So suppose that we know that a local company charges a flat fee of $20 per shipment and an additional $1.50 per pound of the package. So the shipping, the flat fee means no matter how much the package weighs, you have to pay $20 for the shipment. Then you have to pay $1.50 for how much it weighs per additional pound that it weighs. And so the $20 is the initial value. That's the fixed cost, right? The initial cost is $20. Whether the package weighs 5 pounds or 50 pounds, you have to add $20 to it. Then the cost per item, the cost per, in this case, the pounds, right? So the growth rate, in this case, cost per item, which would be my rate of growth, is $1.50 per pound, right? Every pound that the package weighs, it costs an additional $1.50. So 1 pound costs $1.50 plus the 20. 2 pounds cost $3, right? $1.50 times 2 is 3, plus the $20, so $23 total. Alright, find the linear relationship between the weight of the package in pounds and the cost to ship the package, C. Let P be the independent variable. So again, that's going to be the input. So in this case, instead of using X, we're using P. Alright, so we know that the initial value, which is our Y-intercept, was $20. We also know slope. Slope was the rate. Alright, the rate in this case was $1.50, right? For every pound, it cost them $1.50. So that's the rate. And so if we're finding the linear function in terms of pounds, the linear function would be cost equals slope times pound, or in words, it would be the rate times P plus my initial value. Right? The rate is $1.50 times the pounds that we're going to send plus the initial value of $20. And so our cost equation is $1.50 times our pounds plus the extra 20 just for any weight. Doesn't matter how much it weighs, I have to tack on that additional $20. Right? Whether it weighs 1 pound, 2 pounds, 3 pounds, I have to add $20 to it. Alright? And so there is my linear cost equation where M is $1.50. That's my rate of growth. That's how much it costs me for each additional pound. And 20 is the fixed cost, right? Doesn't matter how much it weighs, I have to add $20 to it. Alright, now we're going to use it. So we typically find the equation and then we use it. Find the cost to ship a package that weighs 30 pounds. And so we're given the pounds, right? 30 pounds. And so cost is $1.50 times 30 plus 20, right? Every pound costs me $1.50, and then I have to tack on the fee of $20. And so this cost comes out to be $65. So it cost $65 to send a package that weighs 30 pounds. Alright, the last part of this problem is suppose that somebody sent a package and it cost them $47. We want to know, well, how much did that package weigh? So in this case, we're given cost. Alright, we're given the $47. We want to find the weight, pounds. We're going to use the same equation. Cost equals $1.50 times pounds plus 20. Plug in carefully. The 47 goes in for cost. The $1.50 times pounds. So again, we're solving for the pounds. So first thing you're going to do is subtract 20. And I'm going to go over here to give myself a little more room. So 47 minus 20 is going to give me 27. Equals $1.50 times pounds, divide by the $1.50. So take 27 divided by $1.50, and that comes out 18. So that means they shipped an 18-pound package. Alright, the next example. Alright, so the next one is the cost to produce 1,000 CDs. Suppose that we know the cost to produce 1,000 CDs is just under $400, $3.99. Well, the cost to produce 15 CDs is just $54. Okay, should make sure that it's going to be that much different, 15 and 1,000, big different numbers. is known that the cost to produce C is linear, so it's a line. Alright, find the linear relationship between the number of CDs produced and the cost to produce the CDs. Alright, so it's up to you how you want to let your variables be. I'm going to let C be my cost in dollars, and I'm going to let X be the number of CDs produced. So I'm going to find, you could let C be Y too if you want it to be. My linear equation, cost equals slope times X plus my Y-intercept. Alright, so this is what we have to find. So to find slope, well, we are given 2 points. We're given 2 values. We're given an X value with a cost value. And so write them out. Again, a good idea to write them out. When they produce 1,000 items, well, that would be the X value. It costs them $399. That's the cost value, the Y value. You're also given the other point where when they produce 15 items, it costs them $54.25. So this information is giving you 2 points, a pair of values, an X value and a Y value. In this case, my Y value is my C value, but it's the same thing, right? And so I'm going to use that information in order to find my slope. So in order to find slope, it's the change in Y over the change in X. So I'm going to pick the bigger values to subtract. So I'm going to take my $399 minus my $54.25. And as long as I'm consistent, I'm fine. So I'm going to take my 1,000 minus my 15. So up top is the change in cost. In the bottom is the change in CDs, right? Output, input, change in Y over change in X, change in cost over change in number of values. Alright, up top, I'm just going to type it all out on the calculator. Just, if you do type it out on the calculator, make sure you put parentheses around your subtraction. Comes out to be 0.35, not 25, 35. So that means it costs 35 cents per CD. That's what that means. So for each CD they make, it's costing them 35 cents. That's the change in cost. Alright, so slope equals 35 cents per CD produced. Now I need Y-intercept. So again, it's up to you how you want to find the Y-intercept. I usually just pick a point and plug it in, and so I'm going to pick the first point. And then I know this is slope. So just make sure you're careful when you plug it in. Cost is the $399. X is the items, which is the 1,000. So when you go plug them in here, it's going to be $399 equals slope of 0.35 times 1,000 plus B. And then I'll solve for B. Alright, so 1,000. So the 1,000 CDs cost $350 to make, right? 35 cents a piece. That should make sense. That's $350. Move the $350 to the other side. And so $49 is my fixed cost. And so the final answer is, the cost equation is 0.35 times X plus 49. Right? The initial cost, right, the rate was 0.35. The initial was 49. So 49 was sort of the fixed, whether they produced 1 CD or 50, they have to pay $49. Each individual CD costs the same price. It costs 35 cents to produce. Alright, so there's my cost equation. Find the cost to produce 2,000 CDs. So I want X to be, I said 2,000, 200 CDs. What's the cost? You plug it in. Cost equals, so it's 35 cents for each one of those. So 35 times my 200 plus my 49. And so cost is $119. Alright, if the cost to produce a group of CDs is, again, so same thing. We ask you one, we ask for the cost, and then the other one we ask you for the X value. So the X value in this case we're given that the cost was $311.50. Find X, number of CDs. Alright, again, the biggest thing is just make sure you're careful when you plug it in that equation. So cost is $311.5, X is what we're looking for. So 35 cents times X plus 49. So first thing you do is move the 49 to the other side. So this comes out 265.5 equals 0.35x divided by the 35 cents. And so 750. Okay, they made 750 CDs. And again, check your answer. Always a good idea to double check it. Alright, if I plug 750 CDs in, it should come out to $311.50. And it does. If you plug it in, that checks out. Alright, so that finishes up the 3.1 sort of notes. Now I'm going to do the practice problems that are similar to what you'll see on the quiz and the homework.